So looking at an equation like m squared equals 64, I left some room here to point out that we could approach this with a zero factor property. Meaning, if we move the 64 over, then we can identify what's on the left here as a difference of squares, where the a would be m and the b would be an 8. So we know this breaks down to m plus 8 and m minus 8, giving us m plus 8 equals 0 and m minus 8 equals 0. So giving me a negative 8 and a positive 8. So two solutions, 8 and negative 8. However, we want to also point out there's a form to this equation that going forward we can actually take advantage of. And that's the form of something on one side being squared equal to nothing but a number on the other side. And in this form, we can use something called the square root property as well. How the square root property works. Make sure it's in that form of something squared equals a number, which this is. And then it says take the square root of each side. Now, this is important about this. When you take the square root of each side, so square root of m squared and square root of 64. The reason we're doing this, we learned before, the square root and the square kind of cancel each other out, right? Squaring a square root or the square root of a square. Either way, you're left with the other, what was inside there. So in this case, m. However, what you lose out on is, since this m was squared, you do not know the sign of this m, like we talked about before. When you square something, you lose the ability to know what its original sign was. So as we go to this right side here, and we realize that the square root of 64 is conveniently just 8, we have to account for not knowing the sign. And so there's this symbol called the plus or minus symbol that we'll write initially. It's a plus and a minus sign right over top each other, signifying that this number could be either of those two signs. Now, as far as the final answer, we don't write that. We write them separately. We write that m could be 8 or m could be negative 8. So our solution is just like we saw above, 8 or negative 8. But it's in this step right here, what we call the square root property step, the square root of both sides, that plus or minus is going to show up. And we need to understand that as these problems get a little more involved or involve a little bit more work after the step of the actual square root of those sides. Take a look at these couple examples here. All right, so again, when you see this problem, if you can recognize that all it has is terms that involve squares and constants, there's a possibility that the square root property can work nicely. Let's see what happens. If I subtract the 2x squared over here and add the 12 over there, subtracting 2x squared will leave me with 2x squared. Adding the 12 over there will give me a 48. Now, I don't even like this 2 yet, because right now this is not a something squared on the left side. But dividing out that 2 gets me into there. Now that's useful. That has something squared on the left and a number on the right. Notice the 24, if we had tried to approach this like the last problem and you subtracted 24 over, it's not really easy to see 24 as a perfect square because it's not, right? So this approach is actually even better here to say, all right, now that we've got something squared equals a number, take the square root of both sides. The square root of x squared will give us just x. Now, here is the square root of 24. I'll go ahead and write that. But we need to make sure we remember plus or minus. And we need to also remember that anytime you have a radical, you want to simplify it. So 24, to break that apart to a 4 and a 6. 4 is 2 and 2, 6 is 2 and 3. So if 24 is 2 times 2 times 2 times 3, for a square root, we can see that that pair of 2's can come out front. So you're going to have plus or minus the 2 out front and the 2 and the 3, leaving us that 6 left on the inside. So we always want to simplify the radical, but notice the plus or minus stayed out front of it. It's plus or minus that thing, right? Root 24 simplified. So that's an answer of 2 root 6 and negative 2 root 6. All right, so the next one, a little more involved, a little different looking. It's not a simple quantity or simple value term squared, but it is something squared equals a number. So we will jump right into the square root property. Square root of that entire left side equals square root of the right. The square root of the square leaves you with what's inside, so 3k plus 1 is there, but again, this is where the plus or minus has to show up. Now, the difference here is we've still got multiple steps before we actually have k solved for, so we'll subtract the 1, and generally speaking, when you have a plus or minus term, you like to keep that in the middle of your two terms if you've got them. So this minus 1 coming over, I'll write it first. Negative 1 plus or minus root 2. It's not wrong to put it afterwards, but this is just the more conventional approach, keeping that plus or minus between them. And then dividing by the 3, negative 1 plus or minus root 2 being all divided by that 3, right? Dividing both sides by 3. You could, again, separate them into individual terms also. But that leaves us with our two solutions of negative 1 plus root 2 over 3 and negative 1 minus root 2 over 3. The third example, similar to number 2, we've got an expression squared equals a number. So we'll take the square root of both sides. Here, the square root of the square, leaving us with just t plus 2. Now on the right, we took the square root of a negative 9. Two things. Most importantly, the negative on the inside under a square root, we can't do with the real number system. That turns into an I on the outside. But also notice the square root of 9 will come out nicely to a 3. So that will be a 3i, and even though our square root went away, we just took the square root of both sides, so even here, we still need that plus or minus to show up. Anytime you do this step, anytime you take the square root of both sides, we're going to need that plus or minus 3. Now lastly, I can just subtract the 2 on over, which again I'll write first, negative 2 plus or minus 3i. It's important to notice, again, I'll just point out for both of them, the plus or minus stayed out front of any of these radicals, right? So the first example there, we didn't put the plus or minus between the 2 and the root 6. We don't put the plus or minus between the 2 or between the 3 and the I. It sits in front of that term you got, but when you move other terms over, then it's separating those terms. And so that gives us negative 2 plus 3i and negative 2 minus 3i.